Okay. Um, Today we want to look at first and second derivative tests for non-polynomials. So we're going to look at two rational functions. We're going to look at a radical function. We won't look at sine or cosine. We'll be doing that at a later time. But we want to identify these intervals again. So we need to take the first derivative and the second derivative. I can't write as small as you, so I'm going to invade the space for problem number 2 as well. We are going to take y prime. How do I do y prime? Quotient rule. Thank you. Derivative of the top is times x plus 1 minus 2x times derivative of the bottom. So over x plus 1 quantity squared. Very good. So if I combine these, I get a 2x minus a 2x, which is 0. I get a 2 on the top and an x plus 1 quantity squared on the bottom. Now, gotta understand something here, folks. Look at the original function. Where is the original function undefined? For what value? -1. So therefore, we should see -1 come up in the derivative as well as a spot where the function is undefined. And there it is. Okay? So that's a point that we want to consider when we do our interval testing. But more importantly, true or false, this derivative is always positive. Why? Squared on the bottom and positive on top. So the bottom is always positive because it's being squared. The top is positive because it's positive too. So positive over positive, positive, right? So if you make a number line, the only point that we would put on there would be -1. Okay? Now, let me show you kind of why this works out. If we had, say, 3x minus 6 over x plus 1, and you wanted to set that equal to 0, okay? Say you want to set a rational function equal to 0. If I cross multiply, what happens to the x plus 1 times 0? And then 1 times 3x plus 1, or 3x minus 6 is 3x minus 6 equals 0. So when you want to set a rational function equal to 0, you only need to consider the top. You don't even need to think about the bottom. So in this situation, we've already used the -1 to decide that that's where the function is undefined, so we'll test there. But is the top ever equal to 0? No, it's not. And to confirm that this is always positive, let's plug in a -2. -2 plus 1 is -1. Squared is 1. 2 divided by 1 is positive. Plug in 0. You get a positive over positive, which is positive. So just as we said, we know that it is positive the entire time. True or false? This function has a local max or a local min. False. Why? Derivative is never equal to 0, and it never changes sign from positive to negative or negative to positive. Okay, so therefore, we have a lot of pieces that we're going to be able to lay out here that we already understand. So y double prime? So we're going to take the second derivative, and in order to take the second derivative, what rule should I use? Chain. I'm going to get rid of the quotient rule because I'm going to write this as 2 times x plus 1 to the -2 power. That way I can use the chain rule without using the quotient rule. That's going to be nice, won't it? So what's the derivative of the inside? 1. What's the derivative of the outside? -4 over x plus 1 cubed. True or false? This function is always negative. False. Because you could end up with a cube, you could end up with a negative or a positive, correct? So negative divided by negative would be positive, negative divided by positive would be a negative. So therefore, we do need to check here. True or false? The second derivative is never equal to 0. True. Is -4 ever equal to 0? We just need to look at the top. So therefore, we do not have inflection. We only have concavity. What number would you like to test? -2. -2 plus 1 is a negative. To the third is a negative. Negative divided by negative is a positive. Let's plug in 0. You get a positive on the bottom, negative on top, negative. So this is all the information I need to determine information about this graph. Increasing, decreasing. Max, min. Uh, Probably write it over. Okay, so where's it increasing? So -1 union with -1 to infinity. It's always increasing except for the spot where it does not have a domain value, which is -1. When is it decreasing? Never. Does it have a local max? No. Does it have a local min? No. When is it concave up? Concave down? Does it have inflection? Okay. Does it change? Does the second derivative change sign? Yes. But is -1 part of the original domain? Can you plug -1 back into the original function? No. So the inflection point, there is no inflection point. It does change sign, but because -1 is not included in the original domain, we do not list it. I'm going to pull up my calculator and look at this. If I punch in, what is the function? What do I have? 2x divided by parentheses, x plus 1. And as we examine this function, you can tell, does that look like it's always increasing? Yeah. Concave up, concave down. So it changes at the asymptote, and that is not an inflection point. The asymptote's not an inflection point. No max, no min. Make sense? Okay. Good work. I'm just going to do 3 examples today. You only have 4 problems for your assignment. Okay, number 2. We start again by doing the first derivative. So, y prime is equal to, what do I have to use? Quotient rule. Derivative of the top is times the bottom, 4x plus 4, minus x squared times 4. I distribute through 2x times 4x, 8x squared, right? And then that'll be a minus 4x squared, so I will have 4x squared. And then my linear term will be 8x divided by 4x plus 4, 20 squared. Now, look at your very original rational function. Where is it undefined? Where does it have a vertical asymptote? X equals -1. Is that the same for the derivative? Yes, as it should be. So what we'll do is we will have to include -1 into our testing. But true or false, the top can be equal to 0. Yes, for what values? 0 and -2. So I set the top equal to 0, and this time we can get 0 in the numerator. The bottom, where the bottom is equal to 0, that tells us where it would be undefined. -1, we have to include that because, look at this, Anna. At -1, something funky happened, right? It changed concavity. Even though the top wasn't equal to 0, it still changed concavity. So you have to test the points where it's either undefined or where the top is equal to 0. Okay. Yes, we'll do both. Okay. So let's do this one right here. We will make a number line, and on our number line we put -2, -1, and 0. And I'm going to make a note that this is where we have a vertical asymptote. It's not part of the original domain. So therefore it can't be a max, it can't be a min, it can't be an inflection point. Okay? Now, I'm going to show you a shorter way to get around this. True or false? The denominator is always positive. True. So I don't even need to plug anything in the denominator. I know it's always going to be positive, right? And positive does not account for sign change. But the top, 4x times x plus 2, that can be positive or negative. So that's where we'll plug stuff in. Plug in -3. -3, I'll get a negative times a negative is a positive. Now I'll plug in -1.5. You get a negative times a positive is a negative. Now I'll try -0.5. I get a negative times a positive is a negative. And I'll try +1. Positive times a positive is a. So you can see here that we have um, no sign change at -1. We do at the other two spots. Let's find the second derivative, and then after that we can piece together our maximum, increasing, decreasing, everything else. In order to do y double prime, I have 4x squared plus 8x over 4x plus 4, y squared. What do I have to use? Quotient rule. Derivative of the top is, go get some brain food, come on back. All right. We pick up here. So hopefully you had a good lunch. Try to, sorry about my condition if I sound horrible. So y double prime, we got to take the second derivative. Derivative will be the quotient rule. Derivative of the top is what? 8x plus 8 times the bottom left alone minus top left alone times the derivative of the bottom. How do I take the derivative of the bottom? Chain rule. Let's do the chain rule. What's the derivative of the inside? 4. Derivative of the outside? 2u to the first. So I will have 8 times u, 4x plus 4 to the first. All over what? 4x plus 4 to the fourth. Now, we really have 3 terms. We have 1 on the bottom and we have 2 on the top. What do all 3 terms share in common? 4x plus 4. So I can say factor a 4x plus 4 out of the top, and it will cancel with 1 on the bottom, correct? So when you factor 1 on the top, that will go away. This will be reduced to 1. This will be reduced to 3. So we multiply it out. 8x times 4x, 32x squared. 8x times 4 is 32x, and 8 times 4x is 32x, so I get 64x, and 8 times 4 is 32. Minus, I have an 8 left here. When you distribute the 8 through, what do you get? 32x squared minus 64x all over 4x plus 4, the third. What cancels? That's not too bad, huh? So let's do the second derivative test. Let's I've got some room right here I'm going to use. For the second derivative test, true or false? The top is always positive. It's never equal to 0, is it? So I just look at the bottom, and we only have our -1 spot where we have the vertical asymptote. That's it. So we'll test both sides of that. If we plug in, I don't need to look at the top because the top is always positive. Just look at the bottom. If I type in a -2, I do get a negative value. If I type in a +1, I get a positive value. So therefore, my interval of increasing will be from -infinity to -2, and from 0 to infinity. My interval of decreasing will be from -1 to 3. From -2 to -1, and then from -1 to 0. The local maximum will occur at what spot? Where it changes from? Yep, positive to negative, so that'll happen at -2. Yeah, you look at the first derivative. So this is my first derivative test. This is my second derivative test. Okay, so I plug in -2 to get the y value. What do I plug it into? The original. So I got 4 over -4 is -4. The minimum occurs where you change from negative to positive, and that would be at 0. Plug in 0, you get 0. Concave up, concave down. Concave up from concave down. Whoop, sorry. Struggling. -1 to infinity. And then concave down from -infinity to -1. And then inflection. Does the second derivative change from positive to negative or negative to positive? Yes, but is that point part of the original domain? No, it's not. So therefore, we have no inflection point. Yep. You could have a graph that looks like this. Say you got, say it does that, and then in the middle it could do something like that. So you would have an inflection point right there where it changes concavity. Changes from concave up to concave down, or concave down to concave up. Okay. And if you do graph the x squared over 4x plus 4, it will confirm with everything we have. So, all right, our last example, we won't do 4 today, we'll just do 3. What shape does this graph make? Sometimes you can learn a lot about the mathematics ahead of time by simply just thinking of the graph. Yep. And where does it start? Is it shifted horizontally or vertically? Horizontally to the right, how many units? 2. Because you would plug in 2 to get 0. So it looks like that. So I want you to think about something here, okay? When you take a square root, can you take a square root of negatives? Can you take, could you plug in +1 to this? No. You're only going to plug in values from 2 to infinity because that's the domain, right? So we need to keep that in mind when we actually go about, so like, we couldn't, we need to make sure that when we list our intervals for increasing and whatnot, that we, sorry, that when we list our intervals for increasing, that we don't say from like -infinity to +2, because -infinity is not part of that domain at all. Get my point? We have to consider the domain. So let's take the first derivative. In order to take this derivative, I have to use the chain rule. 3x minus 6 is on the inside, and u to the 1/2 is on the outside. What's the derivative of 3x minus 6? And what is the derivative of u to the 1/2? Over 2 roots of u. Very good. So therefore, f prime of x is equal to 3 over 2 times the square root of 3x minus 6. When I take a square root, what kind of numbers are, when I take a square root, do I get out negative numbers? You only get out positive, right? So therefore, the bottom is always positive. The top is always, therefore the first derivative is always, therefore the function is always increasing. Look at your function. It's always going up, isn't it? If you're going to test something, what's the only spot that you would test? 2. And that's just where the bottom is equal to 0, right? But 2 isn't going to be even part of the domain, is it? Okay? It's an endpoint in this scenario, and the function is not differentiable at that spot. So if you wanted to plug in 2, fine. Plug anything to the right of 2, and you're going to get positive. Plug in anything to the left of 2, and you're going to get undefined. There's no answer for it. So therefore, we know that this is increasing from positive 2 to infinity. Is it ever decreasing? No. Is the top ever equal to 0? And does the derivative ever change sign? So do you have a max or a min? No. We will for concavity. So let's take the second derivative. I can rewrite this as 3 over 2 times 3x minus 6 to the negative 1/2 power. How do I take that derivative? What rule? Chain rule. Inside is 3x minus 6. Outside is 3 over 2u to the negative 1/2. 3 over 3x minus 6 is 3. What is the derivative of 3 over 2u to the negative 1/2? Negative 3 over 4 times u to the 3/2. Because you got to multiply the 1/2, you get negative 3/4. Multiply these two together, and we get negative 9 over 4 times 3x minus 6 to the 3/2. Think about what you have. What does it mean to take something to the 3/2 power? I raise it to the third, and then I square root it. If you square root something, it has to come out positive. So true or false, the bottom is always positive. Therefore, the entire second derivative is always negative. That means it's always what? Concave down. It's always, whoops, sorry. Always concave down. So therefore, we have no concave up, concave down from 2 to infinity. Is the top ever equal to 0? Does it ever change concavity? So therefore, you do not have an inflection point. It's right here. You will come up with the same thing. You plot 2, and this will be negative. It's always negative. If you can tell by looking at it, you don't even need to. Oh, well then the top would be equal to 0 at 0, so I need to include that. Different scenario, right? Look at your graph. Always increasing, never decreasing. Always concave down, never concave up. No local max or min, no inflection point. We knew that ahead of time, didn't we? And our work confirmed it. Question. Because the second derivative, Anna made me put that x there, second derivative The bottom is always positive. If you take a square root of something, you'll get a positive. And we only list the principal root, the positive root. The top is always negative. Negative over positive is always, so therefore you're always concave down. Okay. Here's your assignment. I have 4 problems for you to do. I don't like the problems that are listed in your book. They don't have enough rational ones or radical ones for this section, and I think it's very important that we practice it. 1 and 3 are very similar to what we did today in class. 2 and 4 are just a little bit more challenging. We did one pretty similar to 2. 4 might be a little bit more challenging. But I just want you to do these 4. Again, list intervals of increasing, decreasing, concave up, concave down, local max, local min, inflection point. View it on your calculator to make sure that your graph is accurate and confirmed, that your information is accurate and confirmed. Tomorrow we move on to section 4.4. On Monday, you will be handed a review guide for sections 4.1 through 4.4 that will help you retain the material that we've learned so far. Okay? Nobody look at my email. Cool. Where am I? Here we are. Karina, it's not funny. Good chance you have a work day on Friday. Okay? Friday? No, I don't see any snowed in.